Alright, so continuing here, 3.6 on combining functions with some examples. We just got done talking about combining functions and compositions of functions in 3.6. So let's just take a look at some examples now. We have f of x and g of x, and we want to find f of x and g of x by resubstituting them in. So it says over here, let me just move that. Also do that and find the domain and solve the composition when x equals 3. So basically here is f of g of x. What this is saying is, hey, take g, plug it in there for x. So it's a square root of x minus 2 squared. Well, the square root of a square cancels. So that would be x minus 2 and then minus 3. However, I got to see where they overlap. So where do they overlap? Well, this domain, because there's no roots and there's no fractions with x's in the denominator, this is negative infinity to infinity. This one, however, is a root, so I set the underneath so it's greater than or equal to 0. So I add 2 to both sides, so I know it's whenever x is greater than or equal to 2. So where do they overlap? They overlap from 2 to infinity, basically, is where they overlap. So that's going to be the domain where they overlap, and that is from 2 to infinity. And once again, you can get those to cancel out. X minus 2 minus 3, so it's x minus 5. So x minus 5, and it only is graphed from 2 to infinity because where they overlap is from 2 to infinity is the domain. Now when I plug in 3, 3 minus 5, negative 2 is your answer. So there's that. And there's the domain. Now with this one, I take f, because f is second, and I plug that in. So it's x squared minus 3 minus 2. And when I do that, I get x squared minus 5. Now this is what I'm talking about. This changed, okay? These two, when you push them together, it changed what was underneath the root. It changed what your domain is going to be now. So the point I'm getting at is when you push this together, the domain is what's underneath or greater than or equal to 0. Under here didn't change anything. So it's still what's greater than or equal to 0. Basically, the other way you can look at this is when you go to find domains, don't simplify anything. Don't simplify anything and take a look at the problem and then do the domain. So when you didn't simplify this down to here, you realize there's still a root in it. So the root applies. Over here, if you wanted to, you could still set that up on what's underneath so that it's greater than or equal to 0. It'll still eventually combine together to give you x squared minus 5. So when you add 5 to both sides, you end up getting x squared is greater than or equal to 5. When you square root it, you get plus or minus root 5. If you were to look at the graph of this, it goes off on the edges. It's not what's in between. It's what's on the outside. So you can test the points, or you just look at the graph of the domain, and I realized that it goes from negative infinity to negative root 5, and from root 5 to infinity is where the answer is for that. So plug in 3, because it says to plug in 3. 3 squared is 9. 9 minus 5 is 4. So root 4, you get plus or minus 2 as your answer. So you have f of x and g of x. So we're going to plug them in, but now it's the same thing as the last problem except when it equals 1. First of all, before you even start the problem, I can guarantee you this. When you do an f of g of x or g of f of x, since both of them the domains are going to be from negative infinity to infinity. Since they both are negative infinity to positive infinity, I can already tell you that the domain for them together is going to be negative infinity to positive infinity. But anyway, take g and plug that in. So that's 2x minus 5 squared. And if you wanted to, you could FOIL that out for me and tell me what it actually all is. But right now, I can plug a 1 in. 2 times 1 is 2. 2 minus 5 is negative 3, and negative 3 squared is 9. Over here, I take all of this and plug it in for x. So I get 2x squared minus 5. Once again, the domains for both of these are going to be negative infinity to infinity, because there is no roots and there is no fractions with x's in the denominator. Plug in a 1. 1 squared is 1. 2 times 1 is 2. 2 minus 5 is negative 3. That's my answer. Okay, I kind of can't do this until I know it. There it is. That's what g of x is. So what is the domain? We got to find the domain for these first. This one's all real numbers because I can plug anything in. Alright, anything I want I can plug in. It's going to work. There is no roots, there is no fractions with x's in the bottom, so that's why all real numbers work there. This one, though, the bottom cannot equal 0. That should be a cannot equal 0. It's not greater than 0, it's cannot equal 0. Okay, so keep that in mind. Okay, so just remember that x cannot equal 0, and we will try to finish this problem when we come back.